How's it going, fellas? Um, Let me check and make sure everything here is good. Go to my channel. Let's see here. Okay, make sure everything's good. How's it going, fellas? I don't know why it always does that. It plays through my speaker, but whatever. Yeah, we're good. Okay. Yeah, so since last time, we were doing the Ret to Lipsy challenge for the StackSmash.io platform, and I ended up figuring out what was wrong. So, if you give me 1 second, I'll show exactly why what I was doing wasn't working and how I was identifying the wrong issue. Okay, so I already have the environment set up for this challenge. We're gonna go over here and open this first. Okay. So the main reason why our exploit wasn't working, or the one I made wasn't working, was for several reasons. One of the reasons was the address that I had for the system call, as well as the exit, and also actually the string that we needed to execute a shell. All of those were in memory, like they were linked to the program, but in such a way that if a system that had ASLR on it was present, that it would randomize the address and we would not be able to get execution on there unless we used ASLR bypass. So with this in mind, I found out, or not so much that I found out, I just sort of forgot, and also kind of thought, it's linked to the program, ASLR won't have an effect on it, but in reality it does have an effect on it. And I figured this out by instead just trying different addresses, right? And the addresses that I have right now are actually all in the procedure linkage table. So if we analyze this real quick, let's put a break here real quick. I don't think we need to set anything anyway. Okay, so if we do this, we get every instance of system that we can find it in memory linked to this binary. And here we see that system is also in the procedure linkage table because it gets called in the so I actually don't have the source code for this, but I get a high-level disassembly, particularly the intermediate language using Binary Ninja, and there is a system call, obviously, that gets called in the actual program, in the source code, so it's in the procedure linkage table. On top of that, exit, did we put exit? Let's do this. I think it's until no. Okay, and readoff just gives us information on the sections and segments and what permissions there are and whatnot on memory. So here we have the PLT, and then here we have segments of the program. So this is what gets linked into the program. I thought there was an exit call available. Might be wrong though. Well, we have exit calls linked in the library. Read permissions, read permissions, read permissions. We also did I ever find I'm confused now because okay, it might be the ASLR again. Yeah, we get the same things. Okay, so maybe our exit call didn't work. When I executed the payload, it must have worked. So then, because I didn't get a segmentation fault after I tested it on my machine, I'm pretty sure. Yeah, either way, we got the exploit working. So, and of course, it didn't get saved in my history. Well, first let's examine. It should be the same payload. I didn't change anything. Okay. So we get code execution. We get a shell spawned. Yeah. See. So the exit function, because of ASLR, it randomizes the address and it doesn't actually get called. However, if we do, let's see, what was it? Echo. I think it was sys. File system, maybe. No. Double check. Oh, proc. Okay. Okay, so now if we try it again, yeah, see, it calls exit. We exit cleanly and gracefully. So, yeah, that was the issue. How did I find that out? Well, I mean, I was really frustrated, and so I was like taking a break and just kind of thinking things through. And I noticed that whenever I traced the program, each time I ran it, so if we randomize the VA space again, and we'd have to put the original address that I had beforehand. But when I was running it with the addresses that were linked but weren't in the procedural linkage table, it turns out that whenever I traced it, it kept either giving a segmentation fault or a trace signal or various signals, a legal instruction each time. Like, it gave something different each time. And so I was like, well, why is it doing that? Because it should be pointing to the same spot in memory. And then that's when I realized, I was like, oh, well, ASLR is probably the answer because it keeps randomizing the address space. So, yeah, and we solved it, got the flag, bada bing, bada boom. So yeah, let's move on now. Now what we will be going over today will be ROP chains. So if you don't know what ROP chains are, essentially, I can disassemble this and give an example. Okay. And it's in AT&T syntax for some reason. Why? Okay. So essentially what ROP chains are is whenever you have something, this also includes the non-executable flag. So in the event that you don't have something linked in the procedural linkage table, you can do what's called a ROP chain, and essentially what you're doing is you're picking out bits and pieces from code that's linked to the binary, and you're chaining it in a way that makes it do what you want to do, right? So I already looked through this binary, so I already know in this challenge the creator actually left some helpful functions. So right here you can see he left gadget functions, but essentially it's any amount of instructions that lead up to a ret, right? So this, for example, gadget pop AX ret, push EBP, move the stack pointer into the whatever's pointing at the stack pointer into base pointer, and then pop whatever's on the stack into EAX, and then return. And you chain these calls in such a way where, exactly like I said, it makes you do whatever you want it to. Now this particular challenge, if it'll load. This particular challenge, we're trying to make the program exit with the return value 77. And so, like I said before, here's the cool part about ROP chains is you don't have to start at a specific address. You can do any of these. So you could literally just be like, okay, let's do pop AX and then ret, syscall, all that stuff. So But yeah, okay, so let's try and get started on that. First, let's disassemble the program with Binary Ninja to get a high-level view of what's going on. Okay, so here we can see in the main function, vulnerable function, enter your input, flushes standard output. We have a buffer with hex 40, which is 16, 32, 48, 50, 64 bytes. So 64 byte buffer reads in hex 80 bytes, so that's a lot more. But all we gotta do is start out with hex 40. Do I have the environment set up? I do have it. Activate. Import Poem Tools. So we can do, typically I like to use Pwn debug to generate a pattern. So let's do that. Bring up calculate, my bad, and figure out what hex 80 is in decimal. It's 128, so we can put in up to 128 bytes for the payload. So let's generate that. Byte mode, and then payload, write, payload, and then close the file. Now I don't know if I installed Poem Tools. I'm assuming not, since it's doing its thing right now. Okay. Generate the payload. Okay, cool. So now, we can observe the crash. See what happens. And then since we don't have any system calls besides read, we don't need to be worried about setting follow fork, since none of the functions fork. So here we can see instruction pointer lands on TAAA, and And then we got other stuff too. We got the stack pointer pointing to UAA, which is actually going to come in handy. Because that's what we're going to be STU, yeah. We're going to be overwriting the stack so we can pop stuff off the stack into registers. And I already have an idea of what I want to do, so let's just, my idea currently, since we're looking at the 32-bit exit syscall, all we need to do is pop into EAX1, and then EBX will be the error code, which will be 77. Trying to think, is there anything else? I mean, all we gotta do is look at the gadgets and pass the addresses. So yeah, I mean, let's just start small. Let's try overwriting the instruction pointer with the address we want to start executing code at, and then the stack pointer to see if it pops our value into EAX. So, alright, so we said TAA, which is right here. Oh my gosh. I forgot I'm using Helix bindings, huh? First, let's write down the addresses. So, we're going to try popping EAX first. We can do pop EBX, pop EAX, cool. So that's the address for that. And then right after we overwrite the instruction, we want to overwrite the stack pointer to contain whatever value you want to pop off. So we'll just do stack value, and we'll do all A's. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So like I said before, up to TAA. Let's double check. So STU. So first SAA is base pointer. We don't care about that. T and then U. So TAA, UAA, and everything else doesn't matter. So payload plus equals pack pop EAX into there. 32. Value. Okay, should be good. However, it's bothering me that it's not recognizing our environment. So let's exit out of this and just restart Z. Okay, there we go. All right. Let's generate payload, examine it, make sure everything's good. see if it does what we expect it to do. Don't need to randomize anything since all of these are functions in the program. However, if we were dealing with a little more realistic scenario, we would have to be dealing with ASLR, and I don't know ASLR bypass yet. I haven't bothered to look into it, even though I want to. But anywho, since we know there's a function called vulnerable function, let's break at that, run it with the initial pattern, and we'll do next call up until read. Okay, and here we go. It's pointing to the gadget. Should be the pop EAX instruction, and then if we look 128 words from the stack pointer onward, we should see hex 61 4 times. So let's see if we see it somewhere in here. Right, so that it should be right here. Okay. Just gonna add hex 10. Not leave ret. Yep. And then 616161 is right after. Just gonna ret. Just gonna pop that value into EAX. Yep. Ret from that. And then we should get a seg fault because there's nowhere else to go to. Yep. Cool. So we have a good basis right now. Now here's the thing about ROP chains that's a little difficult, is that we want to have functions continuously executing after the ret. So we want to give it the return address of our next function, and then keep doing the same thing, so on and so forth. So literally all we would have to do right now is, okay, so this is going to be the, okay, so 1 needs to be an AX, so exit code, let's just label it EAX. X1, it should fill it with zeros. And then we should do error code. Pretty sure there's a pop EBX instruction too. So what's 77 in decimal? I forget. 4D, that's what it is. X4D. And then pop EBX instruction. Let's exit out of this, okay. I didn't save my history again, it's fine. ROP. Pipe that to the less. Pop EBX right here. Although, I mean, it doesn't matter. We can use the gadget too. It's nothing crazy. So yeah, we can just do this. Copy. X. Okay. Alright, so first thing we do is exit code EX. We're gonna do error code. Actually, should we be packing our error code? I don't know. I don't know. Let's just do it and find out. So pop exit code, and it should be pop EBX first. Pop EBX, and then we'll have that there as well. Okay, let's see if that works. And then we can actually, this isn't the initial pattern anymore. We can just call this payload.text. We'll rename that as well. Payload. Okay, everything looks right. Just debug it. ROP 0. Payload.text. And skip some calls up until read. Next call again. Instruction. Okay. Looks like we might be good. Return pop EX. That's one. Pop EBX. What's on the stack? 4D. Yep. Ret. And then all you would have to do now is set or you call, make a syscall, which is literally just the hex 80 instruction. Interrupt hex 80. So let's go ahead and do that. I'm getting a call, 1 second. Okay, I have to go here in a second actually, so I may have to put it on pause, but let's go ahead and just find it, write it, see if it works the way we think it's supposed to. In text 80. Now as the caller, we I think we should be good to just make the syscall. Let me double check and make sure it doesn't use any other registers. Yeah, no, it should be good. Okay, so copy this address, add it, payload to should be good. Check the payload real quick. Examine it. Okay, everything looks good. And then we will run that. EBX, pop EBX 4D, and then system interrupt code 0115. I'm pretty sure that's octal. So let's see what exit code we actually got. I'm not sure. 4D is 77. We checked. And it didn't get reversed or anything, so it should be right. I mean, I can try just submitting the payload and see. Let's see. If this doesn't work, then we'll just debug it and see, but should work. 023.
What are you doing?
Yep, and we got the flag.
Looking at the world.
Dope. So that was the ROP chain challenge. Very good challenge. I'm actually looking forward to these challenges right here, because this one, this one has stack canaries, and then this one has full protections. That'll be interesting. So looking forward to it. But yeah, guys, I'll probably be back on here in a little bit, actually. After I finish eating, and then yeah, be moving on to baby's first UAF. Actually, no, I probably won't be. I'm gonna, cause there are courses in this this platform, so I'm literally doing stuff as I learn, and so I think I'm at the point now where I can just finish up and go over the rest of the material and just start branching off and learning other stuff as well. So, but yeah, good stuff. And